Hello guys, welcome to my YouTube channel where we carry on networking practical labs. And if you are new to this channel, my name is Mbebo Johnson Mvola, a degree holder in telecommunication engineering and mobile networks. Okay, so today we are going to be looking at the basic computer networking setup. Okay, we are looking at the basic computer networking setup for communication, and as usual we are going to be using our packet tracer. So let's start with the basic communication between two PC. Assuming that you have two PC and you want to network this PC to communicate, share files, you can simply connect these two PCs together. Okay, you can connect these two PCs like this together. As we usually know, they have to be in the same subnet class. Okay, so let's give it an IP address 192.168.20.1. okay, and then over here we give it 192.168.20.2. okay, so by assigning the same IP address to them, that will set the first base or the first stage for these PCs to communicate together. Now, the second most important aspect that you must take into consideration is the type of cable that you are using to connect these PCs. Normally, we use CAT cable that is clamped to a registered jack 45 RJ45 cable. And the most important thing about connecting two computers together is that you must use what? A crossover cable. Like guys, I told you, we are going to be focusing on direct practicals, not looking much into theories, because this section, this networking lab, is intended for those that have the background theory, but now they are looking for means to top up their skills with hand-on practical. So we use what we call crossover cable, and I believe that in your telecommunication lectures you must have come across these types of cable. We have two types of CAT cable. You have the straight through CAT cable, which is what you can see here on your left, and we also have what? The crossover cable, which is what you can see here on your right. Just by its nature, you can understand why it is called crossover cable. Here in straight through cable, you just follow this color codes to crimp it to what? A registered jack 45. This is a registered jack RJ45 head. Okay, so your CAT cable goes into this registered jack 45 RJ45, which is being plugged on the network card of your PC. Okay, so in order for two PCs to communicate together, they must use this pattern, the crossover cable pattern, for it to communicate effectively. So let's see if this machine can ping this one. Okay, let's see if it can communicate. You go to command line, you say ping IP address 192.168.20.1. okay, and as you can see, it is pinging. Okay, you can see that none of the ping failed because they are directly connected. Okay, good. So let's move to the next. Let's put this aside here. So next, we look at basic configuration between PCs using a switch. Okay, so let's take these PCs and place them here. Place this other one here. Place this other one here. And we get a switch. Get a switch. And we connect them together. Okay, so here we are. Let's say we are in an office setting, and in that office setting we have 4 computers that needs to communicate to each other or share resources. So we connect them like this on a switch. Okay, let's give it some let's give it some IP address. Here we said 192.168.10.1. 10.1. Okay. Come here. No. One 92.168.10.2. One 92.168.10.2. Now we have used that IP address already. 192.168.10.3, and here we have 192.168.10.4. Okay, so let's say we have given it this connection and put a different IP address. Let's try to ping this PC. Let's try to ping from here to here. Okay, let me just put something. Let me just put this IP address for identification purpose. 192.168.10.1. Okay, and then MSO 192.168.10.3. okay, I'll just give this let me just give just these 2 IP address for practical purpose. So let's see if this PC can ping this one. Okay, let me add also this one. Let me just add this other IP address here. 192.168.10.4. okay, 192.168.10.2. I'm trying not to make the video lengthy. Okay, so assuming that we have connect our computers in this manner and assign it this particular IP, so let's see if this PC can communicate with this particular PC. Let's just see if, assuming this one is PC1, let's see if PC1 can can communicate with PC3. Okay, we say ping 192.168.10.3. As you can see, it is successfully pinging PC3. Okay, so there's communication between PC1 and PC3. So let's see if also it will ping PC4. 192.168.10.4. What happened? Oh, wrong, didn't spell the pin well. Pin 192.168.10.4. Okay, I didn't enter it correctly, and as you can see, it is successfully pinging, meaning that what, once we connect our pieces in this manner to a switch, it will definitely communicate. And why is this communication successful? Because this switch is in what is called VLAN 1. You cannot take a switch without erasing all the setups and you do this setup with it and expect it to work, because the switch might be having some configuration that has put those ports in different VLAN. So this setup will work on a switch that has not yet been tampered with, or that is not having any configuration on it yet, because what, all ports in switch by default are on VLAN 1. So since they are in the same VLAN, most definitely they will communicate. Okay, now let's try to see something. Let us bring this aside. Let us bring this aside and try also another setup. Okay, let's try another setup. So assuming that we are in an organization where we have two different offices, and these two different offices are performing a different function and they have different files to share, and you don't want all of them to be in one particular building setup. So let's say we have the IT and we have the sales department. So how do we connect them? Let's say these two pieces are for what? The IT department, and for that reason they will share a common switch. And then the sales department, they have their own switch. Let's also give it some PC. So give it some PC, and then we connect them together. Okay, so here this is our setup. So let's give it some IP address. Here we have 192.168.30.1, and then here we have 192.168.30.2, and here we have 192.168.40.1, and we have 192.168.40.2. okay, so this is our IP scheme. Okay, this is our IP scheme. Let's go into the computer and assign these different IP. So here we have 192.168.30.1 default mask 222.255. Come here, give it 192.168.30.2. And here we have 192.168.40.1, 192.168.40.2. Okay, now let's try to see if this PC can ping this PC here. Let's try to see if this PC can communicate with this PC. So you go to, you say ping IP address 192.168.30.2. Okay, so this PC can ping this particular PC. Okay, let's see if this PC can also ping this PC. You come here, you say ping 192.168.40.2. Is it pinging? Yes, it can successfully ping and communicate. So now let's see if this PC can ping this PC. Now say ping 192.168.40.1. Okay, ping. And as you can see, request timeout, and finally request timeout, which means that what? This PC can communicate with this PC, this one can communicate with this one, but this PC cannot communicate with this PC. What could possibly be the reason? This PC communicate with each other here on this other side. Let's assume these are those sitting in the IT department and these are those sitting in the sales department. This PC can communicate with this, but why can't it communicate with this? The answer is pretty simple, guys. The answer is pretty simple, guys, because they are in different network. Okay, so if you see here, we have 192.168.30.1. okay, now there is something I forgot to do. Let's say what we always, let's say we put the slash notification. So we put the slash notification /24 /24. So in order to avoid the video being lengthy, let's just say all of them are /24 IP address. So if you see the first three octets of the IP address, that's this first three octet stands for the network ID. Okay, this first three octets stands for the network ID, and then this one stands for the host ID. Okay, which means that the first three octets occupy the network address, and this one is the host address. And if you look at it very well, you'll see that this one carries .30, meanwhile this one carries .40, which means that what? They are in different network. Like I said, the first three octets identifies the network or carry the network ID. Okay, so .40 means that this is a total different network, and .30 means that this is a total different network, and two network cannot communicate to each other unless with the help of what? A router. Okay, so to solve this problem, this communication issue, we have to introduce a router in between those switches before it can be able to communicate. In order to prevent this video from being lengthy, we are going to look at it in the next video. So how many basic computer network setup have we seen today? So we first of all started by connecting two computers together, two PCs together for them to communicate. And we said that for you to connect two PCs together to communicate, you first of all give it IP address in the same subclass, and then we connect the pieces to each other using a crossover cable. And I believe that most of you have your background knowledge about cat cable and the different color codes and how you can crimp them into an RJ45 pin. Okay, so you connect those pieces using what we call a crossover cable for it to be able to communicate and share files together. Now let's assume that you have just 4 computers in a single building or in a single setup, and you want those computers to communicate. What you can do is just to simply connect those computers together, or even if it is 5 or 6 computers, what you have to do is you just give those computers IP address in the same subclass, and you connect all of them with a switch, and by so doing they will be able to communicate with each other and share files. Because what, all ports on a switch are on VLAN 1, which is the native VLAN. So once you plug in those pieces, they'll be able to communicate with each other. And here, in order for you to communicate between 2 different networks, you simply need to do what? You need to introduce a router for it to be able to communicate between 2 different networks. So that is what we will be seeing in our next class, guys, how we can use a router to configure or set up communication between different networks. Okay, so don't forget to like, share and comment on my video, for that is the best that you can do for me right now, so that YouTube algorithm will keep promoting this video for others to learn. Okay, so our aim here is to make technical education accessible and easy for many. Thank you for watching. See you in our next class.